In this video we're going to look at how to calculate the concentration of a solution when the absorbance and extinction coefficient are known. Now here we've got two questions which at first glance appear to be different because the extinction coefficient is given in different units. In the first question, the extinction coefficient is given as per micromolar per centimeter, and in the second question it is given as mils per mig per centimeter. However, as we will see, the calculations are both the same. So, using the Beer-Lambert Law equation, where absorbance A is equal to the extinction coefficient epsilon multiplied by the concentration C multiplied by the path length L. From the question we get that absorbance is equal to 0.432 epsilon. The extinction coefficient is equal to 0.108 per micromolar per centimeter. The concentration C is what we're trying to calculate in micromolar, and the path length L is equal to 1 centimeter. Now if we substitute these numbers into the equation, we get 0.432 is equal to 0.108 multiplied by the concentration multiplied by the path length of 1. Therefore, rearranging for C, we get 0.432 divided by 0.108 multiplied by 1, and when we do the calculation we get the answer of 4 micromolar. Therefore, the concentration is 4 micromolar. Now if we look at the second question, we use exactly the same equation. A, absorbance, is equal to the extinction coefficient epsilon multiplied by concentration multiplied by path length. In this case, the absorbance again is equal to 0.432. The extinction coefficient is equal to 0.108 mils per mig per centimeter. The concentration is the thing we're trying to calculate, and in this case is in milligrams per mil. And finally, the path length is, as the question states, 1 centimeter. So again, if we put these numbers into the equation, we get 0.432 is equal to the extinction coefficient 0.108 multiplied by the concentration multiplied by the path length, which is 1. Rearranging this equation for concentration, we get 0.432 divided by 0.108 multiplied by 1, and the answer is 4 mgs per mil. And that's it. That is how we calculate the concentration of a sample when we know the extinction coefficient and the absorbance.